All right, so hello and welcome everybody, and welcome. I'm happy to have all of you here for today's Prodina webinar on the topic of building cloud infrastructure with AI agent teams. I'm happy, or I hope that I come in clearly and you can all see me and hear me. If there are any issues with that, post them in the chat. So today we're going to be looking at building cloud infrastructure for specifically at the use case of using AI agents and bigger AI agent teams to build cloud infrastructure, and the why, what, and the how as to doing this and doing this efficiently. So maybe some of you have heard either me or other people talk on this topic or similar topic in the past. Today, we're going to try to get a little bit more into the weeds of things. So a bigger focus on the how and, what to actually do in order to start implementing these AI agent teams and using them or leveraging them to create value for whatever business or whatever use case you may have. This webinar is scheduled for 45 minutes. I'll try to get through it a little bit quicker than that. So if you have any questions, always feel free to ask them in the chat. I will try to put some time aside at the end of this presentation to answer them. And maybe if we have some time in between, we can also take a quick look. What are we trying to do today? So again, the idea is to use AI agent teams to build cloud infrastructure, and we'll be looking at three specific questions when it comes to that. One, the why. So why use AI agent teams to build cloud infrastructure? What are the reasons for that? Basically looking at the motivation for applying this new technology or this new tool to this specific use case. Then what are AI agent teams? How do they function? How do agents use tools? How do they communicate with one another? And then the how. So how can AI agent teams build cloud infrastructure? What exactly do you need to implement? What kind of tools can you use to not only have this be like theory and a vision that you want to achieve at some point in the future, but actually start implementing? And for the last point, we'll also be looking at a demo showcase. So a quick introduction or a quick overview on myself. My name is Master Schermbeck. I'm an AI engineer and an IT consultant at Prodina. I'm originally from the field of data science. So I've got a master's degree in data science, and I've been working in the field of building data and AI solutions for a few years now. So we can differentiate between like more people who come from a development background and people who come from an AI, machine learning, deep learning background. I'm definitely more of an AI person, and my general responsibilities include things like designing and implementing AI software and AI infrastructure. So this is also something that has changed a lot over the last few years, and what I find really interesting. So like 5 years or 6 years ago, when talking about building AI solutions, what you usually were talking about was training like your own models with very specific architecture questions. So building models in things like PyTorch or TensorFlow, creating these new networks. Then it moved to like a abstraction layer above that, and you started building like more specific model training settings via config files or YAML files, like kind of abstracting away the specific neural architecture. Nowadays, the big focus is really on using pre-trained models like GPT or other LLMs and providing context and tools to make these work the way you want them to. And one of these specific use cases where you can really leverage this in a way that we find worth looking at is building cloud infrastructure. And when we look at how to build cloud infrastructure or what the process for building cloud infrastructure looks like, then this generally starts with a certain assumption or premise. So there's a reason why you want to provision cloud infrastructure, and that being that you think that using infrastructure in the cloud will have a positive effect on your business. You think that you will be more efficient, either from like a cost point of view or from a general process point of view, like time to market, things like that, if you start using cloud infrastructure. And in order to fulfill this, the infrastructure has to meet certain business requirements, meaning things like the implementation of certain types of use cases, maybe even selling a certain SaaS product that can be deployed very efficiently and in a very flexible way. Then things like availability, scalability, maybe things like reporting. But you also have to meet certain technical requirements. So usually these come off from a business perspective, so upper management or product management, well, these come more from people who are on the IT side of things, so architects or software engineers, and they are more focused on things like performance and being able to integrate things into an existing IT environment, compatibility, health monitoring, patching, network encryption. And with these two types of requirements, you usually have both functional and non-functional requirements covered. Well, there's another part to like functional or like non-functional requirements, those being financial and regulatory requirements. Those are especially important when you use the cloud. So regulatory frameworks like GDPR, they restrict you in a certain way to maybe processing your data in certain regions or under certain circumstances. So it's important to also have this fulfilled, and especially if you use certain services in the cloud that are, for example, pay-per-use, then it's important to follow strict financial guidelines. So to have an overview of what your budget is like, both on an overall organization level, as well as maybe a department level, etc., to make sure that you still get to have this positive effect overall. And when you start implementing these infrastructure templates, or you start implementing infrastructure, this is not just something that you want to provision once or that you want to create once, but infrastructure has to be provisioned in a way that's consistent and automatically, or it needs to be implemented this way to both fulfill usually like certain compliance requirements like traceability, and it also is usually a requirement, like an internal requirement from like IT operations, that you need to be able to redeploy all of your cloud infrastructure for things like preventing outages, preventing version drift, and similar issues. Therefore, infrastructure as code is a big topic that's important. So having your infrastructure not just exist in the cloud, but also having it in a way that is standardized and can be redeployed. And obviously, infrastructure as code is a good tool, but it requires you to write code. It requires you to have this kind of abstraction layer from these are my requirements, this is my code, and now this is my code, or this is my cloud infrastructure based on the code. But usually the infrastructure as code, the actual code, is not what you start out with. But you instead have a lot of different roles involved in this process, starting with the business problem. So how are you going to address the business problem, or who states the business problem? Well, that's usually a business stakeholder. So somebody who's responsible for the business success and provides requirements both on a functional as well as a non-functional level. So they define the basic functional and non-functional requirements for the infrastructure, but in a way that's not necessarily technical. Of course, this is very simplified when it comes to complexity. Normally you have things like maybe a department manager, a product owner, a product manager, a project owner, what have you. In this case, we're basically bunching all of that together into a single business stakeholder role. Then you also have, in the case of deploying cloud architect or cloud infrastructure, a cloud architect who designs the cloud infrastructure or the cloud architecture as an overall concept and makes sure that if there are new business requirements, they get integrated into the existing cloud architecture in a way that's sustainable and maintainable and kind of takes things to a less high level, but still not a complete implementation level. So they basically fine-tune the requirements and create like an infrastructure design or an infrastructure vision going forward. But the person who then actually implements these changes is usually not the cloud architect themselves. There's something like a cloud engineer or a role similar to that. So somebody who writes the templates for infrastructure implementation, selects the resources and the providers based on the cloud architect specifications, best practices, current information, what have you, actually researches what options are available and then applies them based on that. But this is mostly an implementation from a technical point of view. So seeing what is valid when it comes to what you can actually deploy, but what you can deploy is not necessarily what you should deploy when it comes to like non-functional requirements like security or financial requirements, especially when it comes to compliance. So you usually have somebody involved who is an expert on this side of things, And they also need to take a look at the cloud infrastructure that should be created or should be developed. And this role is here defined as the FinOps engineer, who looks at these templates generated by the cloud engineer and then validates them or judges them regarding compliance and cost guidelines. And once you have generated a template, or once you have an infrastructure concept that is both technically valid as well as validated through the criteria of cost and compliance, then you can start deploying this. And that's usually done by a role like the DevOps engineer, who is responsible for setting up a deployment process for infrastructure via automated workflows, for versioning, and then also maintaining, updating, patching the infrastructure templates. Putting all of these together, you end up with a process that can sometimes be a little bit complicated. So the process can look something like this. Just soak this in really quick. So you start off with the business stakeholder here on the left, who states the requirements, and they usually state them to somebody who is responsible for the technical implementation, like the cloud architect. The cloud architect then starts designing the infrastructure based on the requirements from the business stakeholder, but this is not always a very straightforward process. So the business stakeholder maybe does not understand the type of cloud infrastructure to the technical level that is needed to really refine things when it comes to what you want to implement. So the cloud architect maybe has to ask some questions to the business stakeholder to refine these requirements, and that's a bit of a back and forth. Then the cloud architect hands things off for actual infrastructure implementation to the cloud engineer. Now, here's also where some issues could appear for, well, maybe what the design that the cloud architect or the business stakeholder thought up is not really implementable in a way that's currently planned. So again, you can have a bit of a back and forth here, maybe a bit of a back and forth here again. And once the cloud engineer has generated a template that is valid for a technical deployment, it also needs to be validated for SecOps and FinOps. Again, back and forth, back and forth. And once you have run through this maybe a couple of times, then you end up with an actual infrastructure concept that's ready for deployment, which then gets deployed by the DevOps engineer if it happens to be actually deployable. And once that is done, you can get, or you start deploying actual cloud infrastructure that can be interacted with. And this is after one of this entire process chain, basically running through this process one time, which is not exactly the whole process to the goal of having like productive infrastructure, because this is usually an iterative process. So the first type of cloud infrastructure that you deploy is not necessarily the one that you end up going with long term. And when it comes to this, how long do you think one of these iterations may take? So in like a best case scenario, this can take like 2 to 3 weeks. So like one sprint in an agile concept. And that is, again, the best case scenario. So the one where nobody is sick, nobody's on vacation, everybody knows what they need to do, all information is available, and it can actually take a lot longer than that. So what we at Prodyna are concerned with is making this process more efficient, or making processes like this more efficient. So what is our large-scale solution to this problem or problems like this? And that's basically the idea of the AI hybrid workforce. And what we mean by that is company-wide efficient collaboration between human employees and AI agents, and basically creating a path to the definition as it is stated on here, meaning an AI hybrid workforce being a heterogeneous workforce composed of humans and AI agents. And that means, or that has basically 4 subpoints to it, which follow one another, starting with heterogeneity, which is the combination of the creativity, the empathy, and the critical thinking that can be provided by humans. So what really distinguishes you as a developer or as an expert is that you can judge whether or not something is important. You can judge whether or not something needs to be implemented. You can have like a large scale vision of what the project should look like going forward, while the AI agent can actually be more efficient when it comes to things like speed, scalability, and data processing. So for example, an AI agent can really quickly generate a code template, but you are the one who can decide whether or not this type of code implementation is something that should be part of the overall product that you want to sell, or whether or not this is not the direction that you want to go with. And putting these things together, you end up basically with a collaborative scenario. So humans and AI agents can work side by side. The AI handling basically the repetitive or data-intensive tasks, research tasks, kind of grabbing things from different systems. And this can help humans focus more on the strategic, interpersonal, or creative work, stepping away from very repetitive tasks and more into things like design-focused tasks. Again, deciding what do you want to achieve long-term, what is important, what is not important, more supervisory roles. And that leads to, instead of trying to replace each other or stepping on each other's toes, the human actors and the AI agents actually augment each other's capabilities, not replacing them, and helping people make better decisions, which is just a net positive for the environment of a corporation that this is applied in as a whole. But it also requires people to move into more dynamic roles. So instead of just doing X over and over again, you need to be a little bit more dynamic in your role, especially as AI agents or AI systems grow and move into other tasks. You have to really focus on the strategic outlook of what you're currently doing and being able to judge whether or not something that's produced by an AI is worthwhile, is something that you want to go with, or it's just something that you can basically iterate on, or maybe even just throw in the trash altogether. So the philosophy between the hybrid workflows as a whole is not thinking about AI use cases in isolation, because that is frankly a little bit of a simplified strategy for modern environments, but instead thinking in things like human job roles, looking at the tasks that these people perform, and then creating agent tasks out of these job descriptions and putting them into a prioritized roadmap of what to work on and what to automate via agents. And this is basically also what we'll be doing for the infrastructure provisioning scenario. So we have the role of a cloud engineer. Cloud engineer does certain things, has certain tasks, specifically writing infrastructure templates, selecting resources, looking for providers for best practices, etc. So we transform this into a cloud engineer agent. This cloud engineer agent has very specific tasks, so very specific scope of what they should do and what they should not do. And in our case, that's like translating high-level infrastructure requirements into concrete templates for infrastructure deployments and following best practices in the process. And this cloud engineer also gets access to tools. This is something that we'll be taking a deeper look at in a minute. But that's basically also very important to have an analog between the tools that a developer may use. So for example, the Azure CLI and Terraform as a tool for infrastructure deployment, then the cloud engineer that we want to design as an analog to the original role, then they also need to have access to that. We'll be taking a detailed look at this later on in the how section. Through using these agents, we can then augment our processes step by step, and a completed process may look something like this. So an agent augmented process that again starts in a similar way. So we start with the business stakeholder here at the leftmost side. The business stakeholder states their requirements, but instead of going back and forth between different roles, we just hand these requirements off to an infrastructure's prompt agent, and this infrastructure's prompt agent implements cloud infrastructure via human approval or human-in-the-loop systems. And then this initial cloud deployment, infrastructure deployment, can be inspected both from business experts who can judge whether or not the business requirements that we may have are met, or what needs to be done in order to meet these business requirements. So this is this business evaluation up here. and a technical expert who can judge things from like a technical, long-term integration side, security side maybe. And this is a bit of a technical evaluation that also gives feedback that can be incorporated into the requirements to start this loop all over again. And if we go through a couple of loops here, we maybe end up with a cloud infrastructure that's actually refined and close to production ready. But the important part is that this one iteration, the initial iteration, instead of taking us multiple weeks to start working with tangible cloud infrastructure, instead of just an architectural vision, we can do in a few minutes instead of days, weeks, months, maybe even. So much for the organizational vision. Now the question becomes, how do we now make this technically possible? What even is an AI agent, and how do these work together? So you may have already seen a diagram like this in the past. So the diagram is always slightly different. The message is always the same. That being, what is an AI agent? An AI agent is a program that uses AI models to autonomously execute a set of tasks in an environment. So this starts with having a user or a system that calls the AI agent give an input to it. And this input is then processed by the program according to some sort of instructions. So these instructions usually describe a task, describe a scope, what the agent should do, like maybe looking up documentation in the web for like a travel scenario or whatever, and also describing what are valid sources and what are not valid sources. And speaking of sources or knowledge, this agent will always have access to a certain knowledge score, or maybe even knowledge and memory. These can sometimes be separated, but at the end of the day, what the agent needs to be able to access is both like general knowledge about the environment that it is in and the context that it is operating in, and also a memory of what it has done in the past and what the current state when specifying or when referencing the task that it's working on is, so it can kind of progress in a linear manner. And then the most important part of an AI agent is, of course, the AI, or the LLM in this case. So we have a foundational model over here to the right. And at the end of the day, all an agent still does is generate text. So this LLM generates a text, and this text can either be just text, meaning that it's interpreted as a reasoning task or a reasoning step, which can just be a thought in a chain of thought in order to solve the problem or the task that the agent is working on. Or it can be one of multiple specified tools. So the agent gets handed a few tools, which are essentially just programs that can be executed with a number of parameters that the program can be called with. And if the LLM here generates one of these tools with a valid set of parameters, then this tool is executed in the environment and the feedback is given to the agent. So like a very simple example would be giving the agent a tool of CD, so change directory, and the LLM generates CD with documents. Then CD documents is executed in the environment, and the agent now knows that it's in the documents directory in like a computer environment, which can then be used for further iteration or further loops here. So this general loop over here is called the react loop. So like reasoning and acting, you either generate a reasoning step, so like an idea or thought, or you act on the environment to progress the task. And at the end of this loop, you give out a response, which hopefully corresponds to the task that you've been given based on the input and the instructions. And generally speaking, if agents or if LLMs themselves are just fancy autocomplete, then agents are just fancy while loops. So while true, do this loop, and then you have some sort of breakout condition to give a response and to continue the overall task or the overall process that was calling the agent. This agent design is not yet completely standardized. There are individual components that are either already or in the process of becoming so. A good example for that would be how AI agents work together. So generally speaking, this basic AI agent setup that you saw earlier works really well for very simplified tasks. But if we go a step higher and try to solve tasks that involve like multiple actors working together, like for example, cloud infrastructure deployment, then you usually need to solve this via AI agent teams. These AI agent teams can have different orchestration patterns. The most common one is pictured up here. So that's having a supervisor agent, and the supervisor agent has access to a few task-specific agents that are specialized on solving certain tasks. You can imagine this like in a kitchen where you have like a head cook and you have a fish cook and a meat cook and things like that, and they basically hand things off to one another instead of like one person doing everything, or basically all of them trying to scream at each other for what they need to do. You have somebody who coordinates these tasks. And this type of agent orchestration can be implemented in a lot of different frameworks. And you usually differentiate between 3 different types, those being no-code. So those are frameworks like Copilot Studio or Lindy, where you just click things together. There are low-code frameworks, which combine clicking things together with specific code snippets when you want to augment something, which are things like Power Platform, which then integrates into things like Azure AI Foundry, or Nodemation is a very popular one on the market right now. And then obviously you also have Proco. So this is the area that we as Prodina live in. We are a system integrator. We develop custom software solutions, and we mostly work with frameworks like Semantic Kernel and LangGraph, which are Python frameworks for actual like programmatic implementation. And if you're talking about agent interaction, you'd be remiss to mention the A2A, so agent-to-agent framework, which is an open source. Well, it was originally created by Google, but they donated to the Linux Foundation. It's a framework for communication beyond individual orchestration frameworks and individual implementations. So it lets agents discover other agents to solve tasks, meaning that you build an agent, another company builds an agent, then you can, and you both use A2A, then you can discover the agent that the other company built using this standard for interaction, like having your workflow agent call an SAP agent to investigate SAP data. It's not that well established yet or that relevant to a use case, but it should generally be kept in mind. So another point of standardization, or that's generally important to agents, is how do AI agents use tools? And there is a pretty matured industry standard for this at this point, which is Model Context Protocol. And a tool use in general is, as I already mentioned, generating a string, matching this to an executable program and their arguments, and then running it. But the question always becomes, okay, how do you provide these tools and how do you make them discoverable instead of having to implement a specific set of tools, like having to implement all of these manually for like basically every tool and every agent that you ever implement. And the solution to that is Model Context Protocol. So if you have an application that uses AI or that should be able to use hosts or use tools like the AI agent that we want to implement, then this is considered the MCP host in the wider MCP context. And inside this host, you have multiple MCP clients. And this MCP client connects to an MCP server, which exposes a certain number of tools. So for example, this could be like a GitHub MCP server, and this down here could be an Azure MCP server, which expose tools relevant to this and to these specific platforms in order to interact with this platform. And what happens on agent initialization is that the AI agent via this MCP client calls the MCP server and then gets a response back from it with all the tools that are available here. And if it wants to use one of the tools, then it again calls the MCP server to execute the tool and gets a response from that. And generally, the message format for that is JSON RPC, which the message protocol, depending on where the server runs. So for like local servers, you just do like standard input output. If it's a remote server, for example, you can host this via Azure API management. Then you do like streamable or HTTP. More of an in-depth view or more of an in-depth introduction on developed platforms for AI agents, for example, if this is a GitHub server, will be done next week in the Prodina webinar coming up. More information on that later. So if you want to start developing agents based on MCP yourself, there's an extensive repository of ready-to-use MCP servers from Docker Hub, and just check this out if you happen to be interested. Now that we know what multi-agent teams are, how do we actually use them to build cloud infrastructure is the other big topic. So we do what we did for the cloud engineer earlier for all of the agents we have involved in this process. So we start with the cloud, or all of the roles that we previously had involved, sorry. So we start with a cloud architect and we think about, okay, what kind of tools does the cloud architect need access to in order to design infrastructure in the cloud? They need to be able to see what kind of infrastructure already exists. So they need access to the Azure CLI to translate business requirements into technical infrastructure. The cloud engineer we already talked about. We have another agent in here that was not present in the roles we looked at earlier, which is the Terraform consultant. Why do we include this instead of integrating it into the cloud engineer? It's a question that you could ask, basically just to keep things as modular as possible. What you really want to pay attention to is not having these agents explode in scope and trying to do everything with one agent. They should really be modular in a sense, not only to achieve the best possible results, but also to like kind of swap things out in the future. So if you want to move from one framework or one tool for infrastructure as code deployment to another tool, for example, moving from Terraform to Bicep, then you only need to swap out like this Terraform consultant with Bicep consultant and swap out the tool here instead of just redoing the entire agent, which tends to be more efficient for like overall enterprise deployments. And you also have a second FinOps engineer, which same as the Terraform consultant has access to web search via Bing, but they are focused on very specific sources for this web search. So like the Azure pricing calculator in order to calculate the costs that an Azure template may incur over the coming months, and also documentation for specific compliance frameworks like GDPR, etc., to maybe even look into current rulings on these frameworks to judge whether or not something is currently, as of now, compliant with it instead of just historically compliant. And last but not least, you of course have a DevOps engineer who has the task of deploying the actual infrastructure via Terraform in that case, so they need access to the Terraform tool, and then to also persist the infrastructure as code in GitHub so it can be iterated upon by consistent processes going forward. What you end up with is basically a diagram or an orchestration graph of these different agents that then work together in order to solve the issue. So you start with the requirements up here. The requirements are given to the cloud architect. The cloud architect passes them on to the cloud engineer. The cloud engineer tries to implement the template. If they happen to have any issues with that, they pass things off to the Terraform consultant for like best practices consultation or current issue consultation. Then that gets passed back to the cloud architect once a technically valid template has been generated. The cloud architect then not only ensures the technical validity of the template, but also compliance and financial requirements by calling the second FinOps engineer. Once that is done, the template is considered deployment ready. Now you can either pass things off to the user once again to get the sign off for deployment, or you can just route it directly to the DevOps engineer so the DevOps engineer can deploy the template and create the cloud infrastructure. Now, when it comes to how we implement this from a technical point of view, there are, of course, as I mentioned earlier, different options for that. The exact approach, of course, depends on the use case. In our case, specifically because we focus on pro code, we use a pro code approach, meaning all the agents are implemented in Python. In other projects, we also use things like Copilot Studio. But in that case, on this case, we try to provide all our requirements via a user interface, which is also programmed in Python, meaning Streamlit. In case you have like a proper front end for production for your specific use case, then you can also just plug this in and have it communicate with the agent backend. Speaking of the agent backend, the multi-agent orchestration itself is done in LangGraph. So LangGraph is kind of a popular framework for orchestrating these different agents, and it's really easy to manage. Just taking a quick look behind the curtain. So generally, you have like what you do in LangGraph is you create a workflow graph, and this workflow graph contains nodes for all of the different agents that you have, like the cloud architect, the cloud engineer, the Terraform consultant, and then you define rules for how they can connect to each other or interact with each other via things like conditional edges, meaning if a certain condition is met or something is implemented by the agent or a task is called by the agent, then you can route to a certain agent over another one. And generally speaking, what we try to do is to have the implementation of the individual agents take place in Azure AI Foundry or LangChain, which are again like Python-based packages. And the important part there being that when we implement a tool, we try to, for the purpose of scalability, provide all of them via MCP. So if the agent uses Terraform, using Azure CLI, etc., all of this is provided via the MCP standard. There are a lot of pre-built or provided, pre-packaged local or remote MCP servers, which you can run or which you can investigate on the Docker Hub site mentioned earlier. Sometimes you have to write your own tools. For example, in the Terraform case or some local development tools, we didn't have access to all that we needed, so we added some additional tools. But all of them were defined using the MCP standard, meaning that it's discoverable in the same way. Now, going really deep into the how, we have also brought a showcase scenario for this today. This showcase being automated notification for report uploads, meaning that we have a scenario like it's the end of the month. We have different reports from different departments, different file formats, and we want to upload them to a single source and be notified about uploads. We want to have secure cloud storage for all of these different reports for PDF and Excel files, and we want GDPR to be enforced for storage and processing. Now, let's take a quick look at the demonstration for this, because frankly, we don't have a lot of time left, but I'll try to make things brief but interesting. So we have a scenario over here for a monthly report storage, and we'll just load the demo over here, which is just a very high-level requirement statement. So we just say that we need a secure place to store a monthly business report, and when someone uploads a new report, we want to automatically send out an email notification to notify people about a report being uploaded and something new being available. And we can further refine this requirement or a general statement of what we want to implement based on different questions we may receive from the cloud architect. So as you can see, they ask questions like, what types of files do you want to upload? How many users, et cetera, et cetera. You can answer that. You can go a little bit more into depth, but sometimes you just want to say no other requirements at this point in time. In our case, we also specify some additional requirements, like how many users we have, what kind of files we have, like PDF and Excel files, and also the email that should be notified, which is my email in this case. And additionally, what kind of resource group and what subscription we want to use for deployment. So this is the resource group RG IAP demo. And if you look into this resource group right now, you can see that it's empty. And if things go well enough, you will see some resources inside there in a few minutes. Looking at the other options that you have here, obviously you can choose different compliance frameworks to be followed. In our case, loading the demo scenario has led to the GDPR framework being selected automatically. Now we can look at the live logs, and these are maybe a little bit too in depth in order to look at all of them individually. But generally, you start with things like system logs, which are just what is happening in the workflow. You can see the cloud architect starts, the cloud architect completes, and then the cloud architect sends things over to the cloud engineer. The cloud engineer generates a template and then hands things off to the Terraform consultant, which is the question, okay, why are they handing things to the Terraform consultant? For that, we can take a look at like the specific reasoning over here from the cloud engineer. And down here, you can see something like, okay, the cloud engineer calls the Terraform consultant with saying the template failed validation due to the use of allow blob public access. And this is basically a result of a tool call that the cloud engineer ran. So down here, you have the cloud engineer running the tool Terraform validate, and you get back error, unsupported argument, Azure M storage account, allow blob public access. In order to debug this issue, the cloud engineer can then call the Terraform consultant, and the Terraform consultant basically gives guidance on that. And this can be a bit of a back and forth process. And after this back and forth process, the cloud architect or the cloud engineer will hand things back to the cloud architect once they have validated the template, that it's something that can be executed. So here you can see the cloud engineer responds back to the cloud architect saying the infrastructure template has been successfully generated, validated, etc. And then the cloud architect hands things over to the SecOps and FinOps engineer. And once that is done, and once they also give their approval of that, you get a reply from the cloud architect in here that says, well, we have your infrastructure as design is ready, and this is what is currently included in that. This is how much it will cost. No remediation is required. It's GDPR compliant, etc. If you're interested in the actual technical details, you can also download the Terraform template, download in secure file, and maybe take a deeper look at what is actually within the infrastructure that you're deploying. If that's not something that you're particularly interested in, and if you don't see any need for remediation, you can just type in please deploy, and it will hand things over to the DevOps engineer in a second. And when the DevOps engineer, so DevOps is starting down here, DevOps will also run the different Terraform tools and then start applying them in order to generate the resources here. While that is taking place, we can take a look at what our main takeaways from this solution or from this process have been, which generally are that AI agents are a tool like everything else, and you kind of need to learn how to use this tool. I've had sessions of a similar kind before where people were complaining that using these tools will just lead to code load, and it's basically a lot of implementation work for something that even an intern could do. Well, now, this could be the case, but it's only the case if you use these tools suboptimally, which is true for everything. And you should really try to define the scope of what individual AI agents do and design your processes around them, which is the main challenge, in addition to providing AI agents with the necessary tools and knowledge, and then designing a framework for how they can interact with each other. So when it comes to the topic of tools, again, we have a webinar next week that will go more deeply into that. but the overall goal of using AI agents is not to automate everything away, but to enable your human experts to work as efficiently as possible. And if you do that, you can really create a lot of real world value. So that means start by investigating your pain points, then considering the tool of AI agents, defining the scope of the individual AI agents, then equipping them with the necessary tools to fulfill the scope, to fulfill their task, and then having human experts look over that in order to make sure it aligns with your overall business goals, and make sure that you're solving business problems using AI agents instead of adding on to them. Now let's take another look at where we are with the deployment. So currently it's still running. Okay, oh, well, we can actually see validation have the so we can actually see that something has been deployed in the resource group, but we also can see that there is an issue with an invalid Azure storage account name. So this is something that can happen. And in this case, what I would, for example, do for this specific task is say, please remediate this, and then it would pass off to the cloud engineer again to make sure that these initial issues are solved and we no longer have to take a look at them. But what you can see is that with the template that we generated previously, we already have some cloud infrastructure, and now we can repeat this process over and over again to really refine this cloud infrastructure to end up with something that is like scalable and viable long term. And when it comes to doing this in a productive environment or in an enterprise environment, what we try to do is basically develop this into a longer journey. So starting with agentic AI and hybrid workforce training, making people aware of why this is important, how the journey towards implementing this goes, then transitioning to mapping job roles to AI agents. So what we did earlier on a larger scale, then making sure that once we have these AI agents defined with their specific scope, that we can actually integrate them into systems and onboard them, making sure in the fourth step that they are aligned or consistent with the user experience that we want to see for the product that we're trying to create, and that they fit into the wider agent workforce with the communication concept that they have. And after these four steps, we can actually start working on AI agent MVP implementation, which means not only having a POC, like what you saw earlier, but something that is minimal viable in the way that it creates actual value, and it's a product version that you can deploy. As I said earlier, if you had any interest in this, or if you found this interesting in any sort of way, then I would also encourage you to check out next week's Prodina webinar on the topic of developer platforms or developer platforms for agents by my colleague Florian. And if you want to sign up for this, make sure to scan the QR code. It will take a little bit more of an in-depth look at if we want to transition from developers to AI agents, what kind of tools that developers have access to nowadays do we also need to make available for AI agents. But for the time being, because we're already like egregiously over time, thanks a lot for listening. Thanks a lot for coming. And if you are interested in any of these topics, always feel free to contact us via social media. Again, if you are interested in whatever events we have available, then that's something you can check out at LinkedIn, at our website, etc. And yeah, for now, that's basically it from my side as well. If you have any questions going forward in the coming days or weeks, feel free to contact me or Prodina, as a general organization. And if there are any questions now, I'll have a few minutes to maybe address them. Currently, I don't see any questions. So if that's the case, again, thanks a lot for joining. And I'll just end the event here. I hope you all have a great day, and maybe we'll see each other in the coming Prodina webinar as well. Thanks a lot. Bye.